Hello everyone. In this fifth installment of the series, I'm going to start installing the components I bought from Arizona CNC kits. First up is going to be the Z-axis. The Z-axis is the vertical axis at the back of the mill. Here's a picture of the Z-axis ball screw assembly that I'll be installing. The ball screw assembly drops in to the column from the top. It's a tight fit inside the casting. In my mill, there was only about a 0.5 millimeter of clearance to rotate the slide alignment block into place. Fortunately, I didn't need to make any modifications to get the lead screw assembly into the column. Getting the slide alignment block to fit into the slide, however, was a different story. Here, you can see the pocket in the slide was slightly too small for the slide alignment block. The slide alignment block was about 31.25 millimeters tall, while the pocket it was supposed to fit into in the slide was only about 30.5 millimeters tall. I've learned that this sort of thing is to be expected. The castings and the machining of the castings has changed over the years. I have 3 saddles here for a Grizzly G0704 mill, and all 3 of them are different. It's impossible for the kit makers to know what version I have. So, on to the modification. I could have made the pocket in the casting larger, or modify the slide alignment block to fit in the smaller pocket. Since the aluminum is easier to deal with than the cast iron, I decided to put a notch in the slide alignment block. I clamped a block of aluminum to the slide alignment block to use as a guide, and cut a notch using a reciprocating saw. The kerf of the saw blade was about 2 millimeters, and worked out perfectly. Next, I reinstalled the gib into the Z-axis slide. I used plenty of oil on the gib and on the ways to make sure everything was lubricated well. I tightened down the gib so that the slide was snug, but would still slide freely on the ways. Here, the slide is resting on the 2 cap screws that secure the way covers. I found this convenient because it holds the slide about 4 inches higher up the column. With the ball screw sitting plumb inside the column, you can see the slide alignment block protruding about 4 millimeters. This is why it's critical that the slide alignment block fits inside that pocket. If the slide alignment block were to rest on the back of the casting, as it is here, instead of being in the pocket, the ball screw would no longer be plumb, which is indicated here by the gap at the back of the column top plate. I positioned the slide alignment block into the pocket on the back of the slide, and backed out the 2 jacking screws to make sure that they didn't interfere with the alignment. I threaded the 2 cap screws into the alignment block, leaving them quite loose so everything was free to move around. Notice, when everything is in its proper position, there are no unusual gaps between the surfaces. For alignment purposes, I left all the fasteners loose so everything could move around and find its own home. Here's an adapter I made that adapts my highly experienced cordless 1/2-inch drill to the shaft coupler. This allows me to spin the ball screws with the drill, and also helps to verify alignment, as you'll see in a minute. My old cordless drill has been around the block a few times. Using the drill and the adapter, I run the slide to the top of the column. Once the slide has reached its upper limit, I turn the ball screw by hand a turn or 2 and lower the slide just a bit so that it's not binding on anything. Since the ball screw is only secured at the top of the column, this seemed like the logical place to set everything to get proper alignment. I jiggled the slide alignment block using an Allen wrench in one of the cap screws, and also jiggled the column top plate. I wanted all the parts to find the natural place that they fit. Once everything seemed to be in its proper position, I ran in the 2 jacking screws until they just barely touched the slide alignment block, and then I tightened down the 2 cap screws in the slide alignment block. For good measure, I jiggled the column top plate around a little bit more before tightening down the 4 cap screws. Now it's time to test the alignment. Using my cordless drill with the shaft coupler adapter, I set the clutch on the drill to a very low level, number 3. With such a light clutch setting, you can actually hold the chuck with just 2 fingers. With the clutch on the drill set so light, if there was any misalignment or binding, the clutch would slip. Just to see what would happen, I set the clutch on the drill to its lowest possible setting, number 1. Since the ball screw will flex slightly as the slide goes lower on the column, the most critical alignment is at the top of the column. I am quite pleased with the result. And that completes the installation of the Z-axis ball screw assembly. In the next video, I'll be cutting into the base casting to make room for the Y-axis ball screw and ball nut. Subscribe if you want to follow along.